Hello all, welcome to our channel Way to Know. So we have one of the video in our channel where we have talked about a Colpitts oscillator based on a BJT. Okay, the simulation of the same is performed, and you can visit this particular video in the link given in the description. So now there was one question from one of the visitor to our channel on how to design the same circuit using a MOSFET. And there was also another question where how can this particular circuit be designed for a 2.4 gigahertz. So 2.4 gigahertz is a very common frequency in the gigahertz ranges, right? People who work specifically in RF do use 2.4 gigahertz as the center frequency. Now, keeping that aside, what can we do with this particular circuit to have a frequency that can be generated from this Colpitts oscillator by just having the MOSFET in place of BJT? Simple. We just need to replace this particular BJT here with a MOSFET. Okay, replace it with a NMOS. Okay, it is as simple as that. NMOS and select an NMOS. So left click on NMOS, pick new MOSFET, select one MOSFET. So where VDS is 30 and you have a reasonable RDS on. Okay, let us select this, and 2 points when we change from BJT to MOSFET is basically BJT is a current control device and MOSFET is a voltage control device. Okay, MOSFET has always has high input impedance. So basically, this particular resistor, even though if it is 1.5K, it doesn't matter much because the impedance is very high. There will be very less current flowing. So if required, we can also change this particular resistance, and the circuit, the tank circuit that is there with the Colpitts oscillator remains the same with BJT, and whatever the frequency of operation that gets generated also remains the same. And one thing is just to ensure that we don't give it too much of VDS, we can have a lower value of VDS, and we can also change the resistors a bit here, and that's it. We are ready to perform the simulation. Let us try to run the simulation. Okay, and let us go to the edit simulation command. For now we kept it 10 milliseconds. Okay, let us just try to run this. Wow, you can see here it just let us snap to that particular you can see. Okay, and sorry, the mouse is creating some problem here. Okay, so if you see here, yeah, so you can see this sine wave. Okay, and let us just try to change the axis here to -10, for example, and then this will be 10. Okay, oh, you can see here. So the frequency also matches as we did with the BJT, and also the clipping that we have seen is also the similar. We haven't done anything, that just the active component that is there is actually changed from BJT to MOSFET. It's just a simple change, and once the active component starts working in its respective regions, you don't see a major difference. Only difference that particularly we see here is the biasing that is to be provided to the base and the gate of this MOSFET varies. Okay, so that is what we have done here, and one thing is, if you give 12 volts here, so the resistive divider creates 6 volts. Ensure that you don't exceed the VGS too much, but it is above the VGS threshold. Okay, so that's what we have to ensure. And there was one more question of um, what need to be done to this particular circuit if I want to achieve gigahertz of frequencies. Very simple, right? If you see this, to achieve 23 kilohertz, we used 5 millihenry of inductor and nanos of capacitor. Now we have to reduce the inductance value as much as possible. Okay, right? Because it is 1 by 2 pi square root of LC, right? So we have to reduce as much as possible to achieve the required higher frequencies. But in practice, that much capacitors or inductors cannot be achieved in discrete values. Correct? So this is where if you go to the RF circuits, these are achieved using MMIC circuits, where the MMICs can, based on the topology that is there, you can achieve the particular frequencies by having those MMIC circuits etched onto whatever the substrate that you have. So this has to be, if you want a higher frequency, this has to be done at the MMIC level, and whatever we are achieving here, or the lower side of the frequencies with the Colpitts oscillator. And definitely Colpitts oscillator has its advantages, right? It's a simple circuit, it's a stable, and you can build it very easily, and with very minimal components you get a very good output. Okay, hope we gave a glimpse of how a Colpitts oscillator, which was actually a BJT based, can be used with a N channel MOSFET. Thank you.